In this video, I want to explore a little bit the difference between log graphs and log laws. So we're all fairly comfortable with the log law here that says if you have 2 times log to the base e of x, that is equivalent to, that it's equal to, log to the base e of x squared. So what I've got here, I've got 2 graphs. Our red graph is the log of 2 times log to the base e of x, so that's this function here. And the second one is log to the base e of x squared, and you get this symmetric pattern. So our log laws say that these two equations are equivalent, but when we graph them, they're clearly not equivalent, are they? They're quite different. But let's have a look at what happens if I graph both of those functions on the same graph. Oh, let's just zoom in a little bit. So what I've got here is the 2 functions graphed on the same axis, and you can see that on the right hand side of the y-axis, this bit here, the lines are in fact exactly the same line. But what we've got for the x log of x squared graph is that we've got this second arm happening over here. Now, our log graph is supposed to have a domain where for this one here, you need that x to be greater than or greater than 0. You need it to be positive. So our domain is only positive x values. Whereas this one here, I can put a negative value into this x value and it will still spit out as a whole a positive value because you're squaring it. So what we've got here is an issue with implied domains. So for our f of x function, we need this. We need x to be greater than 0. But for our log to the base e of x squared, what we need is x squared to be greater than 0. So if we sketch x squared greater than 0, you can see that for all possible input values, you get an answer that's greater than 0. And so what we've got is a domain problem. In fact, for this parabola here, the only value that doesn't give us a value that's greater than 0 is when x is equal to 0 itself. And so our implied domain for this is that x can be any real number except for 0. And you can see on this graph up here that what we actually have is an asymptote running straight down the centre at x is equal to 0. Whereas for our log to the base e of x, we have an asymptote for x is equal to 0. But our implied domain for this one is there. That's our implied domain. And for the other one, our implied domain is all x values except for 0. So I find that pretty interesting that we assume that the log laws are correct and that they work perfectly, but what we've got is that the log laws work for the implied domain for x. So what would happen if we take that idea and we think about these 2 graphs here? So we've got f of x is equal to log to the base e of x cubed. When you put it in your CAS calculator, which you'll do in a minute because you'll want to see what this looks like, make sure that you have the cubed inside the bracket, and then have a think about what would this graph look like. Would it have just the classic log shape? Would it be just a log shape like this? Or would it be one of these shapes? And how could you tell? And what about log to the base e of x to the 4? What kind of shape would that have? And can you describe a pattern that you could use to predict when you get this V-shaped graph for logs of powers of x? Have a think about that. Try it with your CAS calculator and see.